In the next several lessons, we will talk about how to solve quadratics in different ways. In this particular lesson, we'll focus on the zero product rule or zero product property. In previous courses, we've talked about polynomial equations and how to spot them, different from, say, a rational equation or a radical equation or logarithmic or exponential, which we'll learn about all of those in this course. But polynomial equations, we're looking specifically for the degree of the polynomial. So this is a degree of 1 because the highest exponent is 1. This second polynomial has a degree of 2. These are the ones that we're going to focus on in the rest of the lessons this week because these are called quadratic. So whenever we have a degree of 2, we know we're dealing with a quadratic equation. So polynomial is the general term. Quadratic is specific to a degree of 2. Obviously, degree 1 would be linear. We've talked about how to graph those and solve those quite often in this class. Degree of 4, degree of 3, degree of 5, etc. We're going to focus just on that degree of 2. So in this particular lesson, I just want to focus on what the solutions or zeros of a quadratic are. So if I'm looking here, this is what a quadratic would look like if I were to graph it. Notice it makes the parabola shape, so it makes a U shape. The lowest point or highest point, if it's turned upside down, it looks to be right about here. This is called the vertex. Again, these are things that we will not delve into this class, but in a future class that you would, learn how to graph these, etc. What I do want to focus on are these 2 points up here. Notice at these 2 points, if I plug in -4 and if I plug in +5, as I did over here, into this function, that 0 comes out. So the zeros, or the solutions to a quadratic, are what are the x values that I would plug in to make 0 come out for a y value. Now, if I'm looking at a graph, that's very easy. I just look at the point and find that it's -4 and +5. Graphing is sort of a complicated thing unless I'm using a computer to do it, so this is typically not the best way. Algebraically, what we will do is find where f of x, where our function, is equal to 0. So the first way that we're going to talk about is obviously using factoring and the zero product property. The zero product property tells us that if a product is 0, that means that one of the things that we've multiplied by is also 0. So if I had a and b is equal to 0, then either a is 0, either a is 0 or b is 0, or both of them are 0, and we're not sure which. Now, this is the same graph, just a little bit smaller, that we had on our last slide. Again, notice this is that -4 and +5. And now I'm going to look at this function and then determine what the zeros are algebraically. So algebraically, I would look at this and I would factor what I have here. Now, factoring is fairly straightforward when our a value is 1. Remember, a quadratic equation is ax squared. Oops, got an extra squared in there. Ax squared plus bx plus c is what a quadratic equation would look like. In this case, when a is 1, all I have to do to factor is look at the c value and find numbers that multiply to c that have a difference of -1, or would add to -1. So obviously they're going to be different signs. So a lot of times people make a chart of the numbers that would then multiply to 20, 1 and 20, 2 and 10, 4 and 5. And I then would just find the difference between the two. Difference because this is a minus. If it were a plus, we would find the sum. The difference between 1 and 20 is 19. The difference between 2 and 10 is 8, and the difference between 4 and 5 is 1. Now, I want the difference to be -1, and so I want a +4 and a -5. That's where I came up with x minus 5 and x plus 4, using the two values that multiplied to 20 and subtracted to -1. Now, using that zero product property, I would then replace f of x with 0 and say that 0 is equal to x minus 5 times x plus 4. Now, using this property, I know that either x minus 5 is equal to 0 or x plus 4 is equal to 0. So the easiest way to solve would then be to set each of those things equal to 0. In doing that, and again, you don't have to show all of this work, I'm just doing that for your benefit, I would find that my two solutions are positive 5 and negative 4. Notice the same two solutions we found by looking at the graph.